From awaytogarden.com and robinhoodradio.com, this is A Way to Garden with Margaret Roach, your weekly invitation to dig in and grow.
I can ID a lot of plants, and I'm pretty good with the bird and frog species of my region, since I've been keenly tuned into those groups of living creatures for decades. A couple of years ago, a breakthrough book, A Field Guide to Moths, woke me up to the incredible diversity of them around me in the garden, and since then, I always take an extra moment each time I see one to go have a closer look, to try to ID it. By the way, I recorded 2 new-to-me moth species last week out in the yard, which was really fun. Now another landmark book, this one from Princeton University Press, has me putting down my trowel or hose every time someone buzzes by and having a careful look at bees, especially bumblebees. The book is Bumblebees of North America, and one of its 4 esteemed co-authors is my guest today. He is Leif Richardson, a consulting ecologist who's about to receive his doctorate from the Department of Biology at Dartmouth. Welcome, Leif. How are you? And I guess I should say it's L-E-I-F, not L-E-A-F, though I love that it's a good garden homonym, huh? Leif Richardson.
Hi, Margaret. Yeah, got it.
Yes.
L-E-I-F.
Yes. How are you?
I'm fine, thanks.
Yes.
Glad to be here.
Yes, nice to have you. And I will say that as if to remind me to go out of the garden this afternoon and come to the studio to speak to you, a big old bumblebee ran right into me as I was walking in the front yard. You know, sometimes they're on such a mission, it seems like, right. And if you get in the way.
They're not even paying attention to what you're doing. Yeah.
No, he or she was not. It was probably a she, I guess. I don't know. But anyway, I just as a little background before we get started, I am fascinated by your personal research, even beyond your contribution to this wonderful Bumblebees of North America book, about the, I think you, in one of your papers that I read about, you call, you talk about self-medicating bees, like how bees sort of self-medicate by ingesting certain substances from plants. And I just wanted you to sort of talk a little bit about that and give a little of your background, if that's okay.
Yeah. So we're talking because of this book, but the book is a side project, and the thing that I do most of my time is work on this graduate degree at Dartmouth College, and I study the multi-species interactions between bees and plants, and then the antagonists of both of those parties. And so by that I mean the herbivores of plants and the parasites and predators and parasitoids of the bees. Mm-hmm. And what's really interesting to me and to you, I guess, is that plant chemistry, to some degree, mediates these interactions, and also that the effects of the parasites and other antagonists on the bees has an effect on the plants. So there are these direct effects in a pollination mutualism where the bee is transferring pollen between flowers incidentally as it forages and is getting a nutritional resource from the plant. But there are also these really fascinating indirect effects that go on with third parties involved. And so, in particular, what I have found with my research is that, so it's been known for quite a while that the defensive chemicals that plants synthesize
yes.
and use, quote unquote, use in their leaves to deter or kill their herbivores, things like very bitter alkaloids and mm-hmm. Anogenic glycosides, terpenoids of various sorts. Some of the same things that we like as flavors, we use as medicines, we like as odors and colors in plants. These are defensive compounds, but it's been known for quite some time that some of those same chemicals are found in nectar and pollen, which is paradoxical because we expect that those things are on some level meant to attract the mutualists of the plant. And so my work looks at why plants would have these potentially toxic chemicals in their nectar and also their pollen. And so what I found is that numerous plant secondary metabolites, as we call these chemicals, reduce the parasite load of bees that consume them.
So it is medicine.
So it is medicine.
Wow.
I found this in lab experiments where I don't give the bees a choice. All of the bees get hand parasitized, and then half of the bees get the medicine, and half of the bees get a control diet, which is everything except for the plant chemical. And those bees that receive chemicals like nicotine and anabasine, which is an alkaloid just like nicotine in the same plants, thymol, which is a very common compound found in mint family plants and also in basswood trees in the nectar, and then callopol, which is an iridoid glycoside found in turtle head or Chelone glabra,
right,
as well as other plants in the Plantaginaceae, the plantagos, plantains. Those four compounds all significantly reduce the parasite load of these bees.
So it's kind of like when I listen to you talk about this, and then I think, well, then why do people doubt the efficacy or the usefulness of herbal medicine? Do you know what I mean? Because in a way, this is a very I don't know if I should say primitive. I don't mean it in a derogatory sense, but a primitive form, the most fundamental, basic, natural form of it all has a purpose, and it provides the plants are providing multiple things to the insects that are utilizing them. They can be defensive. These elements can be to ward off problems, or they can also bolster other actions and so forth. So it's kind of fascinating.
Yeah,
isn't it?
And so we know a lot about herbivory or animals eating plants, and we know that in many cases, these chemicals are toxic or deterrent to the kind of generalist herbivore that would feed on lots of different kinds of plants.
Right. They take a bite and it doesn't taste very good, and they sort of go, "Nah, I'm not going to do that."
Right. But there are specialist herbivores that are adapted to lay their eggs only on those plants because of the presence of the chemicals, and then to eat the plant to resist being harmed by the chemical, and to actually sequester the chemicals, so that in many cases these are insects that I'm talking about, like butterfly larvae. So the larva can have 10 or 20 times the concentration of the plant's baseline concentration of the chemicals, and so the bug is using these chemicals as a defense against their own parasites. So that we know a great deal about, but what we don't know is, do these mutualists of plants sequester the compounds from nectar and pollen, and whether or not they sequester them, and by that I mean this concentration of the chemicals, can they benefit from them? And then third, if they can benefit from them, which I've shown in my work, do they self-medicate, which would mean, do they change their foraging behavior in response to becoming parasitized?
Wow.
And so I'm in the middle of some field experiments that indicate that, at least in some cases, they do. And so in field experiments, I change the chemistry of the nectar in flowers, and then you
naughty boy, you.
Yeah. It's science, and then the bees. I time bees visiting these flowers, and later I assess the parasite load of the bees that have done that foraging. And what I find is that for certain parasites, when the bees have the parasite, they spend longer at flowers that are more bitter, that have higher concentrations.
Oh, so they know they need it or something. Oh, it's
right.
amazing.
So, I can't tell you that they know they need it, but there's mounting evidence that, at least in some cases, some bees and some plants, they are consuming more of these plant chemicals when they are sick as compared to when they are not sick.
Love it. Well, so let's talk about bees. Let's talk about, how many first just give us sort of briefly place bees, and especially bumblebees, sort of in the order of things. Who are they related to, and, where do they fit in?
Well, bees are in the insect order called Hymenoptera, which also includes ants and wasps and sawflies and a few miscellaneous other taxa. So the closest relatives of bees are wasps, and they diverged many millions of years ago, but they're closely related to each other.
And how can I tell a bee from a wasp? I know that's stupid, and I should know that. But...
No, it's not stupid. In fact, what many people consider to be a bee is the furry thing that looks a lot like a honeybee, and they because most people aren't specialists in this, most people do not know that there are many species of bees that closely resemble wasps, and you would just overlook them as a wasp if you did not know. So, in general, bees are more hairy than wasps, and in particular, the hairs on bees are branched. At least all bees have branched hairs, at least somewhere on their body.
Oh.
And so they can look very feathery, just like a bird feather under the microscope, or they can be more with all the branches coming from one origin, or they can be bifurcating repeatedly. So these feathery hairs, they insulate, but they also aid in the collection of pollen, or so was the theory. Most bees, the females, collect pollen to feed to their offspring, and so they have a pollen-carrying structure, and we call that a scopa, and a scopa is usually a morphological characteristic of the exoskeleton combined with hairs. And so if you think about, everyone knows what a honeybee leg looks like, and you have that big, wide area on the hind leg.
Right.
This is the scopa of a honeybee. It's a concave area on what is called the basitarsus of the hind leg, and then it has long hairs that arch over it, so the bee can pack pollen inside there and then cover the pollen with the hairs. On other bees, the scopa is a brush of hairs as opposed to a hairless area with a hairy fold over it. In other bees, it's not on the leg at all. It's on the underside of the abdomen, or it's on the thorax. And there are bees that carry pollen internally.
So those are some of the differences between these brushed hairs, these feathery hairs, and the scope are some of the differences between bees and wasps?
Right, and so you won't always be able to distinguish bees and wasps,
right.
But look for these pollen-carrying structures, and are generally more hair than
Okay. And how many species of bees are there in the United States? I mean, there's a lot.
This book that I wrote is about bumblebees, and there are very few bumblebees, relatively speaking. There are only 46 species.
46 bumblebees.
On the continent of North America.
Right.
But we have nearly 4,000 species of bees total, including the bumblebees, in the United States. And so it's a great diversity of different types. Most of them are not, again, what you know as a bee. Most of them are solitary in their lifestyle as opposed to social. So the males and females mate, and then the females go off and they lay their eggs in a nest and provision it with pollen and nectar and seal it up, and they're done. As opposed to rearing their offspring and then successive generations of a worker caste coming, and then later reproductive individuals all in the same colony in the same year. That would be a social bee.
And so the most sort of famous and best known and easily identified even by novices social bees are honeybees, and their hive is obviously a very social, it's kind of a, we all recognize that, but bumblebees are social as well in a slightly different way, aren't they?
They are, right. And so I like to tell people that honeybees are not native to North America. They were brought here in the 18th century by Europeans as an agricultural animal. Right. So they're very useful as pollinators, and of course, because they make honey and wax and other useful compounds, products. And so they are highly social. There's a very highly developed, complex social structure and behaviors. Bumblebees are native here as well as throughout the rest of the world in temperate and montane places, with a few exceptions. They are social, but they're not considered to be have as complex a social structure as honeybees. And so they do have a caste system where there's a reproductive female who we tend to call a queen. There are non-reproductive females who are workers. They're unmated. They actually can lay eggs, but they generally do the foraging and the caring for their sisters and brothers, and not the actual egg laying themselves. And then there are reproductive individuals who are males and who are new queens who have not yet mated but leave the colony and eventually do so. And so the other principal distinction between bumblebees and honeybees that people will be interested in is that bumblebees don't make much honey, and the reason is that they are annual, like an annual plant in your garden. The colony does everything in the summer and dies out by the end of the summer. Right. And then the only individual from the colony that survives the winter is a mated new mated queen. So all the males die, all the workers die, and the queen who founded the colony dies. And
right.
so overwintering, it's just mated females, and they have no need to store resources because they're hibernating.
Right.
Whereas
so
honey, you have this feeding that goes on all winter inside the hive.
Now, can bumblebees sting? I didn't know that. I don't know that. I realize either.
They can and they do.
Okay.
They are reluctant to sting. They're not particularly dangerous unless you're allergic to their stings.
Right.
And unless you are close to their nest.
Right.
Otherwise, it's hard to get stung by a bumblebee. They avoid it as much as you do.
So in early spring, I'm, cleaning up the garden, I'm crawling around, and I'm in the leaf litter, and I'm taking things, uncovering crowns of plants that are emerging and so forth. And inevitably, I uncover what I suppose is a nest, and it's a female who's, is the word gravid? What's the word for a mated female? Mated female, right?
Or gravid.
Yeah, so she's gravid, she's mated. So she's hibernated over the winter, and she's going to find some pollen and nectar, and she's going to provision a nest once she gets going in the spring and lay the eggs and rear the next generation. And are they like in under leaf litter, in logs? I mean, what kinds of places do they look to spend the winter? It seems like if I was a tiny little bumblebee and pregnant to boot, mated to boot, it would be a rough winter in the north.
Yeah, it's pretty amazing. And we know relatively little about the overwintering. We know a lot about how the colony develops and social structure and parasites and predators and all. It's hard to find them going to their hibernation spot, and there are very few studies that actually look at what's happening
interesting.
During the wintertime as far as the temperature and whether they succumb to their parasites or underground predators like shrews.
Right.
But here's what we do know. They tend to go to places that are not going to heat and cool rapidly on a daily basis. So It's often north-facing slopes in forests or places other than out in the open in a field. And they dig a hole. Sometimes they use an existing abandoned rodent burrow or other underground cavity. They probably will use walls of buildings. But they spend the winter in a hibernating state. They do have food reserves that they're consuming slowly as they hibernate in their bodies. They don't store food externally for this. But yes, you often disturb them when you're cleaning up your garden in the spring.
Yes.
And those are bees that were hibernating. They're probably ready to come out. You probably haven't done them much damage. But at this time of year, and starting sometime in April, where you are and farther north where I am, they begin to look for their nest sites. So if you're in the garden in the early spring and you see bumblebees flying around near the ground and landing and moving a little ways and then landing again, they're often searching for a nest site.
Interesting.
And investigating holes in the ground.
Yeah. So let's see, we have about 5-6 minutes left, and I want to talk about one of the main thrusts of the book, which is bumblebee identification. The book states one of its primary aims is to make the process of IDing bumblebees as straightforward as possible, but they're not easy to tell apart, and even one of the prominent experts quoted in the book says that bumblebees are morphologically monotonous. Is there like a very high-level sort of 101 on looking at bumblebees with a sharper eye to knowing how to look at them? Like, how should I, when I see them, should I look at size? Should I look at color pattern? What should I do if I want to try to understand them a little better as a novice?
The key word that you said is look. And so to me, the thing to do is to pay attention and to, as much time as you can, observing them and paying close attention to their structure and their behavior. It's a little bit like bird watching, if you're familiar with that, or you mentioned moths. At first, it's a little overwhelming. There are so many different color patterns and body sizes and songs. This is a little harder. This is harder because they're smaller, and we sometimes need to destructively sample in order to really know which species is which.
Right.
But you can learn to identify perhaps half of the bumblebees that you'll see in your area, whatever your area may be, without catching them. So beyond just being a careful student of nature, I would say if people pay close attention to the color patterning of the three three different body segments. So there's the head, the thorax, that is the middle segment where the legs and wings are attached, and the abdomen, the back end. There are distinctive color patterns, and then also paying attention to the body shape. So if you look at the book, we tell you how to distinguish males from females, and to some degree how to distinguish workers from queens. Those are both types of females.
Right.
And I'll just say that the color patterning is not enough to identify them in all cases. And in fact, in many cases, you need to look at some morphology of the face, the shape of the eyes, and the distance from the top of the eyes to the bottom of the eyes, and so on.
The book is fascinating because it has these illustrations. I think I told you when we spoke on the phone that they look like a series of signal flags to me. It's like it breaks them down into these graphic patterns and gives you the idea of roughly what you're looking for. It's fascinating.
That's right. So look at the rough color patterns. If listeners do get the book, we talk about these groups of species that are very similar. So if you start noticing that a bunch of the bees that you see are half yellow and half black, you'll see that as a contrast to the ones that are stripes of yellow, black, and then that include an orange stripe. And then beyond just the gross color morphology, you can then think about how to distinguish the bees that have an orange stripe from each other. There are 2 or 3 species, depending on where you are, and how do I distinguish those from each other?
So I had hoped that we'd have time to talk a little bit about neonicotinoids, the chemical substances that have been such trouble for bees and are in an ongoing way. I'm going to have to do that on the website because we won't have enough time, but in the 2 or so minutes that we have left, I want to I love learning new words, and from you I learned a word, and I'm probably going to mispronounce it, aposematic, APOSEMATIC.
Right.
So having to do with sort of mimicry and speaking of appearance. So what does it mean?
Yeah, so we say aposematic.
Aposematic, thank you.
I'm not sure if there's only one pronunciation or not, but what it means is when animals have a warning coloration. So they have adapted to have a color pattern and also a behavioral a suite of behaviors that tell potential predators that they are dangerous. And so this is common in nature. You can think about the monarch butterfly caterpillar, the adult monarch butterfly, things that are orange and black, the coral snake that's black and yellow and red, right? These are color patterns that are either understood on an innate level by predators or on a learned level. So
and bees definitely have that, yeah.
Many of them are yellow and black and red or orange. And their main predators are thought to be birds, and birds don't innately know that those colors are dangerous, but after sampling one bee, studies have shown that birds such as blue jays will never eat another furry thing that's yellow and black.
One bee is enough. Thank you very much. Well, as I said, I had hoped to talk about the neonics. We're going to do that on the website on the accompanying article that's going to go with this. I'm going to have some copies of the new book, which really opened my eyes literally to the diversity of bumblebees in my garden. And I thank you and your co-authors, Leif Richardson, of Bumblebees of North America from Princeton University Press. As I said, I'm going to get a couple of extra copies and have a giveaway on the blog, and we're going to have a lot more information about bee conservation and the threats that they're under. It was so good to talk to you. Thank you so much for taking the time from the field work to join me today.
You too.
Yes, and nice to speak to all of you. You can always find me at awaytogarden.com, of course, or at facebook.com/awaytogarden. And don't forget, don't miss an episode. You can get the podcast on Stitcher or iTunes for free.
Away to Garden with Margaret Roach is a joint production of awaytogarden.com and the smallest NPR station in the nation, Robin Hood Radio.